Two wires carry currents in opposite directions as shown in the figure below. One conductor carries a current of 10 amperes. The point A is the midpoint between the two wires, and the point C is 5 centimeters to the right of the 10 amp current. I1 is adjusted so that the magnetic field at C is 0. We are then to find the value of the current and what is the magnetic field at A. To perform these calculations, we wish to be very careful about the signs that we apply to the magnetic field contributions from each of the two wires as we attempt to add them up to get the total. In order to be clear about their directions, I'm going to label the wire on the right with a blue line. When we apply the right-hand rule, we curl the fingers of our right hand so as to form a circle and hold the thumb extended. The straight thumb will be laid along the direction of the current, which will be towards the top of the screen, and then the fingers of the right hand will be used to indicate the direction of the magnetic field as it circles around the wire. What we'll notice is that everywhere to the right of the blue wire, its magnetic field contribution will be directed into the screen. And everywhere to the left of the blue wire, its magnetic field contribution will be directed out of the screen. And I'm going to draw two such indications in order to cover all three regions of the figure. Let's perform a similar analysis of the left wire. In this case, we'll color the wire red, and remember that the current is directed down towards the bottom of the page. Again, curling our right hand and recognizing that the curled fingers are the circle of magnetic field and the straight thumb indicates the current. When the thumb points towards the bottom of the page, we will find that the magnetic field will be into the page everywhere to the left of the red wire, but it will be out of the page everywhere to the right of the red wire. What we see in this case is that to the left of both wires, and also to the right of both wires, the two contributions are in opposite directions and will tend to cancel. However, in the region between the two wires, the contribution from both the red and the blue wire are in the same direction as each other and reinforce one another. We'll adopt a convention such that any magnetic field directed out of the page we'll call that plus, and any magnetic field contribution directed into the page we'll call that minus. Now that we've made a careful and methodical labeling of all the signs of all the terms, we're ready to begin our analysis. And we're going to begin at the point C. The magnetic field surrounding any straight wire follows the formula B is mu 0 I over 2 pi r. Labeling the red wire as wire 1 and the blue wire as wire 2, we'll be able to deduce our two magnetic field contributions. The distance between the point C and the red wire is 15 centimeters, and the distance between point C and the blue wire is 5 centimeters. The red wire makes a contribution out of the page, which is therefore positive, of an amount mu 0 I1, which we have yet to deduce, over 2 pi times R1. The blue wire at point C makes a contribution into the page, and so we will assign that a negative sign and follow the same formula, mu 0 I2 over 2 pi R2. The total magnetic field at point C is gotten simply by summing these two terms, and in the problem we've been told that we will adjust current 1 until such time as the magnetic field at location C is 0. This expression can then be solved for the current in wire 1, and because R1 is triple R2, this will lead us to a total of 30 amperes as the current in wire 1. For our final calculation, we need to consider what's going on at point A. Since point A is the midpoint between the two wires, both R1 and R2 are equal to 5 centimeters. As we can see in the figure, both the contribution from the blue wire and the red wire are directed out of the page, which we've selected as the positive direction. Therefore, the total magnetic field at point A is going to be the simple sum of the two contributions, mu 0 I1 over 2 pi R1 plus mu 0 I2 over 2 pi R2. Plugging in the numbers, we get a grand total of 0.00016 Tesla. And that ends the analysis of the magnetic field at point A.